All right, we are now on our final section for this unit, 11.4, and we're going to be finding the area of regular polygons and composite figures in this one. So for our first definition here, we have an apothem, and that's a line from the center of a regular polygon. And remember, whenever that word regular is before a shape, regular polygon, regular pentagon, octagon, any of those things, all that means is all sides are congruent. Okay, so if you forget, just make sure you make a note of that. So, as I was saying, an apothem, line from the center of a regular polygon at right angles to any of its sides. So in this case, I went ahead and labeled that's going to be segment FG in our given drawing here. And often that's going to be labeled with an A like this, okay? For our next one, we have the central angle of a regular polygon. So that's the angle formed at the center of a polygon. That pretty much goes without saying. And our formula is just going to be 360 over n, which I believe we did in 2 or 3 units ago. So again, our n is just going to be equal to our number of sides. And again, usually the number of sides are labeled with an S, okay? And for our final box here, we have the area of a regular polygon, and our formula is 1/2 times our apothem, so that A, times our n times S. So A, as I said, is apothem, n is our number of sides, and S is going to be our side lengths. So side lengths. So I'm going to go ahead and label our drawing here just a little bit. We have all of our sides here have S's, and then that's it, okay? But I do want to go ahead and say, let's do a practice round right here. I want to find the angle BFC. I want to find the measure of that. So because that's a central angle, okay? So if I wanted to do that, I would just do the measure of angle BFC is equal to 360 divided by how many sides? We see we have a pentagon. Pent means 5, so we should get 72 degrees, okay? So I'm going to go ahead, like that last video, we're going to just do the ones I have highlighted here. So I'm going to suggest you do number 1 on your own, check your answers with the key. But we are going to do number 2 together here. We have you just built a hexagon table, find the area of the tabletop below and of triangle GAB. So to start off, I'm going to do my area of the hexagon. Now, your notes should say a regular hexagon here, okay? So we can assume that each one of these side lengths is 3 feet, okay? Now, GH is given to us as 1.3. That right there, remember, so this segment right here, that's making a right angle with one of our sides, so this right here is our apothem length, okay? So for our area of this hexagon, all right, I will write area of hex. I'm going to do 1/2 times my apothem length, which is that 1.3, times my number of sides, which is 6, times my side lengths, which are 3. So again, I'm going to enter that in my calculator, and if I do all that correctly, I should get 11.7. And again, make sure you have your units, so in this case, feet squared. And then for our last part, our triangle GAB, that should be easy. So area of triangle GAB. And again, make sure you're starting off with that 1/2. I see a lot of you just forgetting to write that in, okay? So we have 1/2 times our base, which in this case is 3. And then our height in this case for that triangle is just going to be our apothem length, so 1.3. And once we do that in our calculator, we should get 1.95. And again, with our units, feet squared. All right, here. So moving on down to number 3, we're going to do this one together. And this is probably one of the more challenging ones on the worksheet, okay? So I want to make sure we go over at least one of these together. Now, we're trying to find the area of this regular pentagon. And as you can see, all we have given to us is this length right here is 9 centimeters. And basically, I'm going to think about that as a radius. As you can see, if I were to draw that circle around our shape, that would be our radius. So I need to find a couple of things to find the area. Remember, your formula is going to be that 1/2 times your apothem length, which we don't have, times our n, our number of sides, which we can easily count, times our s, so our side length. So again, here we don't have our a and we don't have our s, so we need to find those before finding the area. And if you think about it, we haven't used our central angle formula at all yet so far. So this is where this is going to come into play. Okay, and you'll see why here in a second. Looking at what's given to us, we can find that angle KOL, we can see that that's a central angle because right here we have one side length is in between those, or in between the angle, okay? So the measure of angle KOL is going to equal our 360 divided by our number of sides, which is 5, and we'll get 72. Now, we can see that we have right triangles within this as well. So if I wanted to just find, let's do this angle right here, so angle POL, all I would do is divide that 72 by 2, or multiply it by 1/2, okay? And that's going to give me 36. Reason I'm going to do that is because I'm going to use that 36 to find my two missing side lengths here, my A and then my S, okay? So let's go ahead and find our apothem length first. So this red side, where is it? That red side here. Notice how I have an angle, I have a side length, and now I'm looking for my adjacent side, my A, my apothem. So I have an adjacent and I have a hypotenuse. So out of my sine, cosine, and tangent, which of those uses adjacent and hypotenuse? That's your cosine. So I'm going to do cosine of 36 is going to equal my adjacent, so my unknown A, over my hypotenuse, which is 9. And if I go ahead and solve for A in that case, I'm going to go ahead and get that A is equal to 7.28. And again, if you don't get that when you enter it on your calculator, please send me a message and I'll walk you through how to change your calculator to degrees, okay? So now that I have my apothem, I have two different options here. I can either use that new side length and my hypotenuse to use Pythag, or I can use my 36 degrees again and find this length PL, okay? I'm going to personally use the angle because I could have technically found my apothem length incorrectly. So using that angle, since we know for sure that's to be true, that way it's going to maybe be a little bit better to use just in case we did make that mistake with this side length, okay? So now that we're dealing with PL, and again, we're going to use that 36, and we're going to use our hypotenuse since that was given to us, that we have our opposite over our hypotenuse, which is going to be our sine. So sine of 36 is going to equal, I'm going to say PL, over my hypotenuse, 9. So PL in this case is going to equal, once everything is said and done in my calculator, I'm going to get 5.29, okay? Now, for my actual formula, my area formula, up here I need my S. But PL is not my whole side length of that shape. That's what KL is. So to find KL, or my side length here, all I have to do is double that PL that I just found. So 2 times PL, which is going to be 2 times 5.29, and we get 10.58. Okay? So now that I have all of that, all I need to do is plug in my newfound information into that equation at the very top. So I'll go ahead and do that in orange here. So our area will equal 1/2 times our apothem, which we found is 7.28, times our n, which is 5, since we have 5 sides, times our side length, which we just found is 10.58. And when everything is said and done and you enter that in your calculator, we should get 192.556. And then again, make sure you have your units. So in this case, it'll be centimeters squared. Okay? So anytime you have problems like this, when you just have one item given to you in a regular polygon like this, that's when you're going to have to use that sine, cosine, and tangent again, okay? Obviously, if you have any questions at all or are confused on anything I did, please reach out and I will help you out as best I can, okay? So moving down here, we also have number 4. I'm not going to go over that with you. I'm not going to go over 5 either, but I did write out some hints here for how to approach the problem. Same idea with 6, and I will say 6 is very similar to the one we just did. So that was number 3. You're going to have to use your sine, cosine, tangent things for this kind of problem as well. Now moving on down to number 7, I do want to do this one together. So I went ahead and wrote out that we're going to find our total area by doing our area of our triangle plus our 2 rectangles here. So I just want to go ahead and make sure we're all understanding the labeling of this. So to start off, let's find our area of our triangle. We can see that we have one of our base here is 76, and we can see that this 28 is the same length here, okay? So our area of our triangle is going to be super easy. That's just going to be our 1/2 base times height, so 76 times 28. And we should get 1,064 inches squared. Then I'm going to go ahead and do my area of rectangle 2. And right away we can see that we have a 88 by 28 rectangle. So for our area, we're just going to do 88 times 28. Simple enough, and we'll get 2,464 inches squared. And then our last one, our area of our rectangle 1, we can see that these 2 side lengths here, I'll do in red highlight, these 2 side lengths here are congruent. They're both 28, okay? So here, I'll do everything in red here, 28. So this entire side length here is going to be 28 plus 28, which is 56, okay? And then this length up here we need to find, okay? So we can see that this entire length down here is 102. So same idea, right up here is 102, okay? And we can also see that this side length, I'll do here in purple, is 88. So this length up here that I'm drawing in purple is just going to be our 102 minus 88, and we'll get 14 for that missing side length, okay? So here we can see that our rectangle number 1 is a 14 by 56 rectangle. So if I go ahead and multiply that out, I should get 784 inches squared. And again, for my total area, I just want to add up these 3 numbers that I just found. So if I go ahead and add all of those up, I should get 4,312 inches squared for my final answer. Okay. And finally, down here with number 8, I did initially highlight this for us to do together, but I'm thinking you can handle that on your own. I'll just walk us through how to approach this first one at least. I'm going to split this shape up into a rectangle and a trapezoid, so you're going to use a little bit from last week's lesson. And then here we see we have a parallelogram on the right, and we have a kite within it. So we're going to do our area of our parallelogram minus our area of that kite. Okay? Hopefully that helps. And again, if you have any questions, please feel free to reach out, especially about number 6 and number 3 here. Okay?